In this video, I'm going to show some select problems from Lesson 16 in the Oklahoma Supplement, and this lesson is on creating line graphs. Let's begin on page 93 in your journal, and we're going to look at question number 3. Question number 3 says, represent each data set in a line graph. So we have a set of data and then a little graph that's set up for us over here. And this data for number 3 says 1 day's temperatures, and we have temperatures from 12 p.m. to 4 p.m. and then we have temperatures. So along the x-axis, that's the horizontal axis right here, that's where we're going to put our times. And I'm going to go ahead and start, and I'm going to put 12 p.m. right here, then 1 p.m., 2 p.m., 3 p.m., and 4 p.m. And I'm going to label this as time, and I'm going to put in parentheses p.m. so that I know that these are all afternoon times. Along the y-axis, this is where we're going to put our temperatures, so I can go ahead and label temperature. I'm just going to label temperature in degrees Fahrenheit and abbreviate there. Now I see that this graph has a break in it, which means that we are cutting out a large chunk of this of what would be blank data right here in the graph. So that means that even though the graph would start at 0 right down here, this next line is not necessarily counting by the same interval that all of these other lines are counting by. So I'm going to start with my lowest piece of data, which is going to be 62 degrees, and that's what's going to be right here. And now I need to figure out what I'm going to skip count by, what my interval is going to be. And I need to go to 72, so if this is 72, let's see if that we can do by 2s. 64, 66, 68, 70, 72. Yes, we can. So I'm going to skip count by 2s, and this is where you're going to have to write kind of small to fit all this in there. But now that I've got my graph completely set up, I can graph the data. So at 12 p.m. it was 62 degrees. At 1 p.m. it was 65. That would be in between 64 and 66. Notice that I'm plotting the data on the lines. At 2 p.m. it was 72 degrees. At 3 p.m. it was 66 degrees. And at 4 p.m. it was 64 degrees. What I want to do once I've done plotted my data is connect the dots. You'll want to use a straight edge to do this, even though I'm not right here. And then lastly, we'll want to give it a title, and this is one day's temperature. Temperatures. So here's my graph, 1 day's temperatures. And now I want to try to interpret this graph. So look at what's happening in this graph. And just over the course of time, I would normally expect the temperature to rise throughout the course of the afternoon. So this is making sense so far, except that I know from just personal experience that the hottest temperature in the afternoon is later in the afternoon than 2 p.m. Usually the hottest temperature occurs somewhere between maybe 3 and 5 p.m. Probably somewhere around 4 p.m. close would be a more accurate time for the hottest temperature of the day. And yet we have the temperature decreasing rather drastically between 2 p.m. and 3 p.m. At 2 p.m. the temperature was 72, at 3 p.m. it was 66, so the temperature went down 6 degrees just during the course of that 1 hour. So just looking at this data and trying to figure out what's going on, I can probably make an inference that at this time of day between 2 p.m. and 3 p.m. something happened. Either clouds came out, or it started raining, or a cold front came through, and the temperature continued to decrease from 3 p.m. to 4 p.m. but not as quickly. So maybe this was a cold front, or maybe this was rain during this time of day. If the temperature at the end, if we had plotted another point at 5 p.m. and if that 5 p.m. temperature had gone up, then we could definitely know that something has happened here, probably rain, if the temperature had gone back up. If the temperature continued to go down, we wouldn't necessarily be sure that it was rain. It could have just been a cold front. But definitely something has occurred at approximately 2 p.m. right here, because the temperature drastically decreased in the afternoon, and we normally wouldn't expect that to happen. Let's next look at number 4, which has a title of hair growth, and I'm going to go ahead and put that on my graph. So we're going to graph hair growth, and we're graphing hair growth over the course of 5 different weeks, and it looks like I could just put 1 week on each line here. Remember, this is a line graph, so we're putting our data on the lines, and I'm going to label this is just different weeks. And we know that length is going to be on the y-axis, and this length is measured in centimeters. Now, our length would not necessarily start at 0 because this is hair growth, and if you were starting at 0, you would assume that the person is completely bald. So in this case, it looks like our minimum is 0.6 of a centimeter, and the maximum is 1 2/10. So we can start at 0 here and then put a break in the graph. And then right here, put 0.6, and I'm going to write these as decimals just to make it easier for me to fit on here. Now, if I make this 0.6, I've got to get all the way to 1 2/10. And if I count by 1/10, 7/10, 8/10, 9/10, 10/10, 11/10, 12/10, that is 1 2/10. So I'm okay to count by 1/10, 1/10 at a time. Remember that 10/10 is the same thing as 1 whole. So then we have 1 1/10, and finally 1 2/10. Now I'm ready to plot my data. So the reason that we had the break in the graph is we cut out all of the empty part right here of the data, because obviously nothing is happening. This person, whoever this is, already had their hair grown out a certain length, so there would be nothing going on in the data there. So after 1 week, their hair was 0.6 of a centimeter. After 2 weeks, 7/10. 3 weeks, 9/10. 4 weeks was 1 1/10, and 5 weeks was 1 2/10. So now that we have this data plotted, we're going to connect the dots, and then we're going to look at the trend in the graph. And in this case, the trend in the graph is clearly increasing. So we would say that this person's hair is growing at a fairly steady rate. We can see that this is very close to, if we put our pen right along this, it's close to a straight line. It's going up at a fairly steady rate. If I were to plot one more point, and let's say point for week 6 was right here, and let's say week 6 was right there. If I were to plot that point on this graph and then connect the dots right here, we can interpret some more about this, because clearly this person's hair was 1 2 centimeters, and now it's cut in half of that. So something happened between week 5 and week 6, and the most plausible explanation for that is that this person just got a haircut. We're next going to look at page 94. It says the table shows the amount of growth of 2 sunflower plants that Juanita grew for her science fair project. So we have a table that's showing the height of the plants over the course of 12 different weeks. We have a control plant, and we have an experimental plant that she did something to. We're going to graph the heights of those 2 plants. And unlike our previous examples, these plants do have a week 0. So we must put a 0 along the x-axis of our graph. After that, I'm just going to count by each week. And because this graph was perfect, it fits perfectly because it was designed just for this problem. But these are going to represent our weeks. Along the y-axis, we're going to put the height of the plants. So along the y-axis, I'm going to carefully write height in inches. Height in inches. And we know that we have to go all the way from 0 to 101 along the y-axis. So somehow we have to be able to skip count and get all the way to 101. So if we count by tens, 10, 20, 30, 40, 50, 60, we won't get there. So it looks like we're going to have to count by something larger. Let's try 20s. 20, 40, 60, 80, 100, 120. That will get us there with a little bit of room to spare. So I'm going to count by 20s. 20, 40, 60, 80, 100, and 120. And you'll have to write really tiny to be able to squeeze that in on this graph. And now we're going to plot our points. Now this is going to be a double line graph, which means we're going to have one of our pieces of data in one color and then our other piece of data in a different color. So for the control at week 0, I was at 0. At week 1, I was at 7. Now this is going to be a little bit tricky to plot because between 0 and 20, 7 is somewhere right in here, and there's no way I'm going to be very accurate with that. Week 2, I was 14. Again, it's going to be very hard for me to be very accurate. Once it gets a little bit bigger, I can start being a little bit more accurate. Certainly on week 4, where it's 40, I can be pretty precise. Week 6 is 68. Week 7 is 82. Week 8 is 90, which is halfway. Week 9 is 99, really close. Week 10 is exactly 100. Then we have 101 and 101 again. I'm going to go ahead and connect these dots. And it looks like our trend for the control plant is to obviously get higher as the weeks progress. We would expect a plant to grow. It looks like the plant reached its full maturity at about week 10 or so, because it didn't really grow anymore after between week 10 and week 11. So now our experimental plant, we're going to graph it on exactly the same graph, except I'm going to use a different color. And this is going to be a little bit tricky because the first part of it's going to kind of overlap. So the experimental plant at week 0 was also 0. At week 1 it was 3. Week 2 was 10. Week 3 was 15. 4 was 18. 5 is 21. 6 is 24. 7 is 28. 8 is also 28. 9 is 32. And then we've got some 32s. Actually, 9 was 28. Then we got some 32s the rest of the way. Doesn't really matter that if I'm off a little bit on here, because it's really hard to plot these exactly anyway when all of your data is pretty much right in between 20 and 40. So there's no way that I'm going to be able to make that perfect with this scale on the graph. The only way I could do this graph better would be to use a much larger piece of graph paper, where I could make a much smaller scale, or than counting by 20s along the y-axis. I would now need to give this graph a title, and the title is going to be sunflower height. Sunflower height. And we also need to have a key, and my key is going to be that green is the control. Let me move this so you can see it a little bit better. I'm just making a little mark, and then the red is the experimental. We could have also just drawn an arrow to each one, but I need to have a key somewhere so that I know what this green line is and what the red line is. So now to interpret this graph, and it appears that the control plant, like I said before, reached maturity somewhere between week 10 and week 11, because after week 11 it didn't grow anymore, whereas the control plant reached maturity also around week 10. The only difference is that the control plant obviously didn't grow anywhere near as high. It's not like the control plant just started falling off and dying. It continued to grow all the way up to about the same point as the control plant did, but whatever Juanita did to the experimental plant caused the experimental plant's growth to be significantly less than the control plant. And looking at questions 7 and 8, it says, what is the scale of each axis? The scale of the x-axis is from 0 to 12. Its interval, however, is 1 because we're skip counting by 1 each time, 1 week at a time. The scale of the y-axis is from 0 to 120, and the interval of the y-axis is 20 because we're skip counting by 20s each time. Question 8 says, would your scale be different if you had only had the control plant data to graph? The control plant is this green one right here, and the answer to that would be no, it wouldn't be any different because the control plant is the one that caused our y-axis to be skip counting by 20, caused it to need to go from 0 to 120. If we were only graphing the experimental plant, on the other hand, our data, our scale would definitely be different because we would not need to go from 0 to 120. We would just need to go from 0 to at least 32 because the experimental plant's maximum data was only 32 inches in height. So the control plant, our graph is going to stay the same even if we had just graphed it. The experimental plant, if we had only graphed it, we would have been able to go from 0 to 32, skip counting by much smaller numbers, so our graph would have been more spread out and it wouldn't have been looked like it was all squeezed together like it does right now. The last question I want to look at is on page 96, and this is on the homework page, so I'm not going to work it out, but I want to look at question number 2. We have a graph right here. It says depth of the scuba diver, and we have a data table here. We have the x-axis already done for us. Its scale looks like from 0 to 35. But the depth, how deep the diver is going, we don't have a scale on this y-axis at all. So what I recommend you do is, you know that the depth is going to have to start at 0, because at 0 would be at the surface level of the water. However, we don't have any data between 0 and it looks like the minimum is 22. So you're probably going to want to break in your graph, and you're probably going to want to start on this next line right here at 22. And you definitely need to go to at least 42. So what you're going to have to do is you're going to have to figure out what can you skip count by, what is your interval, so you will get from 22 to at least 42, and you really don't want to go very much past 42. So if you're at 22 right here, don't skip count by 100 and get to 122 right here. Yes, that will get you, past 42, but that would leave all of your data squeezed in just between these two lines right here, which would not be a very good graph.